Okay, so today I'm going to be doing an overview for question 9 of the applied maths paper, which is hydrostatics. Things I'm going to cover today is the 4 question types, formulae to use in each question type, the language used in questions and how to tell which question type we're being asked, and finally things to be aware of when doing your hydrostatics questions. So our question types are as follows. I've got my floating object questions, I've got fixed object questions, I've got pressure questions, pressure in a liquid questions, and I've got the mixtures. So when we figure out what question type we're doing, we write the relevant formula up the top of our page where we can see them while we do our question. So what formula do we use for, or formulae do we use for each question? So let's go with the floating formulae. So very first thing when we're doing a floating question is make sure that you have the correct formula for upthrust. For anyone who doesn't know, upthrust is basically the upward force that a liquid or gas exerts on a body floating on it. So you can see that there coming up. And what I failed to mention in my other video was that it acts through the centre of gravity. So make sure you've got the density of the liquid multiplied by the volume displaced multiplied by gravity is the formula we're going to be using for upthrust. There. Now, so we've got that one. The next bit is what I like to call the floating formula. And that is that upthrust is equal to weight. So basically, just to explain this a little bit, is that when the upthrust is larger or greater than the weight, when an object is in a fluid, the object will rise until the upthrust is equal to the weight. So that is our floating formula. Okay? And since we're using weight, we're going to use our really handy formula on page 56 of our formula in tables, which is that weight is equal to density of the object by the volume of the object by gravity. So here are all our formulas. We've got, for floating questions, we've got weight, we've got upthrust, and we have U is equal to W. Another really important thing to note, because it does come up a lot for a floating question, is the volume of volume and area of shapes. So we've got a lot of spheres, cylinders, cubes. So make sure to know where they are around page 10 and 11 of your formula and tables. So when you see that it's a floating question, we're going to write these clearly up at the top of our page. Take a second just to make sure they're right, especially that upthrust formula. Make sure you've got the right one before you dive into your question. I've done a video already on a floating question, so if you want to check it out, it's 2002 question 9A. It's on my channel. So next up, we have the formulae for fixed object questions. So first of all, we're going to encounter our second formula for upthrust. So this time, when an object is fixed, it's going to be the fraction of the object submerged multiplied by the weight of the object multiplied by the relative density of the liquid all over the relative density of the object. Now, because this is a fraction and relative density is there and there, you can use just the normal density, but I like to use relative density because it keeps the numbers just a little bit smaller. The next bit is not a formula, but what you're going to use a lot for fixed objects is the fact that when the acceleration of an object is equal to 0, all net forces are equal to 0. So that means that forces acting in opposite directions are equal. So just to do that quickly for you there, with this rod here that I've drawn, I'm just going to make sure we know that this is forces. Okay, so first of all, with every object, we're going to have weight acting through its centre of gravity. So I'm going to go with that. That's going downwards because it's gravity. And here, this little section of the rod is submerged in water. So the centre of the section of the rod submerged in water. So we can agree that there's no upthrust acting on this section here. It's only the part submerged. So we're only dealing with this section here. So the centre of gravity of this little piece is going to have the upthrust acting on it. And last thing we have is our little force here, because it is for the point that's supporting the rod. Okay, so now we've got two forces going this way and one force going this way. So if our net forces are equal to 0, I'm going to call this the negative direction. I'm just going to explain this a little bit further. And this is the positive direction. So basically what we end up with is that F plus U minus W is equal to 0, because when our acceleration is equal to 0, our net forces are equal to 0. So what we can say then is that F plus U is equal to W, and we'll use that. And we'll use that a lot when we're doing doing rod questions, fixed questions. So the second part of that then is going to be our moments. So we do have a formula for that. So the moment of a force is basically its turning effect. So you can find this on page 54 of your formula and tables. The moment of the force is equal to the magnitude of the force multiplied by its distance from the fulcrum. Okay, so let's deal with our forces here. So we identified our three forces. Let's see what their turning effect is. So our fixed point here is going to be acting upwards. So I'm just going to do an upward arrow there, or kind of turn upward arrow, and that's our F. But its distance from the fulcrum is equal to 0, so I'm just going to notate that there, that its distance is equal to 0. So I've got my magnitude of my force by the distance, so that actually has no effect. Our second one was weight, so weight is acting downwards, so it's going to try and turn it this way. So I said this way was my minus direction and this way was my positive direction. So I'm going to call that minus W, and let's call this L here because it's the middle, so that's going to be multiplied by its distance to the fulcrum. And then I've got my other force, my last force here is U. We said that was in the positive direction, plus U multiplied by its distance to the fulcrum. I'm just going to call it like Q. I'll do like actual tutorial videos on rod questions so you can see in more detail how this works. So basically what this means, because this rod is in equilibrium and it's not turning, it means that U is equal to W, and you can see that here because there's no acceleration, the moment's equal to 0. So we've got, sorry, not U is equal to W, but the moments of this part are equal to the moments at this part. So that's really important when answering questions about rods, yeah. Okay, so our next formula that we use a small bit, I think it's come up 3 times since 2001, is trigonometric, with the rods question, is trigonometric functions. So you can find them on page 16 of your formula and tables, so make sure to know those. I wouldn't write these out for every single rod question. It'll be pretty apparent when you read the question whether you're going to use your trig or not, just to be aware of those. And another one that we use a lot for rod questions is our minus B formula. So you can find that on your formula and tables, page 20. If you do maths, you should be very familiar with this formula, so just make sure to note that. And again, for for fixed questions, what we have come up a lot is our, we need to be aware of our volumes and areas of shapes. So that has come up again, so it's important. So now here are our formulae and kind of like points of information that we'll use for our fixed questions, so just be aware. So next up we have our pressure questions, okay? So obviously when we're dealing with pressure, we need to have a formula for pressure. So you can find that on page 57 of your formula tables. So it's pressure is equal to the density usually these questions are pressure in a liquid, so it's going to be the density of the liquid multiplied by gravity multiplied by the height of the liquid in question. Now, I think it came up once since 2001, that thrust is there as well, so I just added it there in the bottom, but it doesn't come up often, so don't worry too much about it, but just be aware that thrust is equal to pressure by area. Okay, so a kind of concept we need to know for our pressure questions is that we need to know is that pressure is equal at equal depth. So this is why we can do our YouTubes the way we do in a constant fluid, because that the pressure is equal at equal depth. So say if I drew a line here, say this is full of some liquid, let's say mercury, and if I draw a line here, the pressure acting here upwards and here is going to be equal. And why that is because the pressure acting in all directions is equal at equal depth, so it's upwards, downwards, anyway, the pressure is equal, okay? So I'm going to do another example of that there. Like this is a constant fluid. If I make a point here and call this P, if we do it at the exact same depth here, it's going to be the exact same thing. So all along this line, pressure is going to be equal. Another thing to be aware of is that pressure increases with depth. It's never come up, so don't worry too much about it, but it's just good to be aware of it. So last but not least, we have our mixture questions. So in mixture questions, there's two formulae that we need to be aware of. Our very first one, obviously, density of a mixture. So it goes like this. The density of a mixture is the density of the first liquid involved in the mixture multiplied by the volume of the first liquid involved in the mixture plus the density of the second liquid involved in a mixture multiplied by the volume of a second liquid involved in the mixture all over the volume of the first liquid involved in the mixture plus the volume of the second liquid involved in the mixture. So that is really important. It's not in your log table, so learn it. And our second thing for mixture questions is we need to be able to manipulate this formula here, which is density is equal to mass over volume. So that's in your formula in tables page 57. So you need to be able to realise that it can be written anyway. So I could say density multiplied by volume is equal to mass. I could say that density divided by mass is equal to volume, and so on. You need to be able to manipulate that formula. So here are the two we need to know for our mixture questions. Let's move on to the language used in the questions. So I've gone through 2018, 2001 because I have no life and I've highlighted the keywords which tell us what type of question we're dealing with. So we have an awful lot of floating questions. So straight away, what's going to happen when you have a floating question is it is explicitly going to say the word floats or floating. It's usually floats every single time. The only one little weird one I had was in 2015 where it said it was a ship. Like if you actually think about that and you think of like how a ship works and like you can tell that it is floating in water. So that was the only time they made you kind of work for it a little bit. So our second type question was fixed. So for fixed, you've got a lot of rods and it's not a lot of times that they explicitly say the word fixed. We get a lot of, like here in 2016, it says supported by the edge, tied by a string, hinged at a point, stuff like that. But you will see the diagram of the rod and they'll tell you it's a rod. So when we're dealing with rod questions, we know it's going to be fixed. So we know what formula we have to use there. So another one is the pressure questions. They are a little bit more cryptic. They won't tell you explicitly pressure. They actually have never, since 2001, they haven't used the word pressure. So if they start talking about heights of fluids, like here we've got in 2011 we've got oil is 12 centimeters from the top. So if they start talking about heights of fluids and if they give us a diagram, usually you can see from the diagram, sorry, I'll get to one there. Now see, we've got our YouTube, you can see from the diagram and from the question it says that mercury is this many centimeters from the top. We're talking about the length of the column of water. So if they're talking about the length of liquids, not the length of objects, the length of liquids, we're kind of saying this probably is a pressure question, okay? And one year they asked about thrust. As soon as you see thrust, you know you're dealing with pressure as well, because as we said earlier, thrust is pressure by area. For our mixture questions, they almost always say mixture, but sometimes they'll say alloy. So here in 2004 we've got mixed, 2005 alloy, so just know that an alloy is a mixture of two metals. And in 2001 we had something about a compound object. It was a compound object. Here we are. So compound object, so like quite simply, like a compound is a mixture of two substances. So make sure, it even says it here, compound object made up of two bodies. So when they say compound, it means it's a mixture, so just be aware of that. So it's not always going to be as clean cut as there's only fixed questions, there's only floating questions. A lot of the time we've got a kind of a mixture of both. Like I'll show you what I mean here. So like in 2011 2008 we've got a question here and it's got the floating here and fixed here because it says tied by a string. This question actually has come up twice. This type of question, like the exact same thing, has come up twice since 2001, so just be familiar with this. I definitely practice that question if I were you. So it came up as well in 2014. Here we are here. So be aware of that, and I'll do a tutorial on that question soon. So the other one we had was 2007. So here we are, we've got, it's typed by a string again, so we have string type to point, that's what tells us it's fixed, and we have mixture involved here as well, so it says mixture. So now another thing I've noted for you is how often awareness of shapes and volume and area of shapes come up. So here we are, shapes. It's everywhere. Like since 2001, there has been 12 times an awareness of shapes, area and volume has been necessary to answer a question. So make sure to note that in your formula and tables for shape, area and volume. I think it's page 10 around there. Another note I've said already, is where the trig formula come up. So it'll be with a rod. So it will either give you the degree of the angle like here, or it will ask you to figure out the angle. So when it gives you the degree, usually we'll use it to find this length here to answer our question. So finally we have our things to note. Okay, so these things come up often, so just make sure you know them. So very first thing is our density and relative density, okay? So relative density is just the density multiplied by, relative density is density divided by 1,000. And the reason that is our second point to note is we need to know for hydrostatics questions the density of water. So the density of water is, I actually don't know the units for it, which is really bad, but is 1,000. So just know that. Another thing I said was important is to know the formulae that are in the formula and tables. So like I know this is not in the formula and tables, that relative density is density divided by 1,000, or density is relative density multiplied by 1,000. The density of water is 1,000. Density of the mixture formula is not in the formula and tables. You need to know that. What else isn't in the tables? The upthrust formulas. So you have your floating one, and there is the one for the fixed as well. So that's that one there. You need to learn these. What I call the floating formula isn't there. So you need to know these pretty much off by heart if you want to do well in your hydrostatics question. Another thing I have is apparent weight has come up once or twice. So the apparent weight is basically the weight of the object minus the upthrust acting on it. I'll probably do a video on one of those questions. So know all those formulas off by heart. You need to be able to use them, and as well know exactly where the formulas are in your formula and tables, the other ones that you need to use. So weight is on page 56, density page 57. I've got my trig functions there on 16, minus B formula page 20, moment of a force is page 54. The density formula is around here somewhere, and that is on page 57, so make sure you know where to find those, and like look at them, lads. Like when you're doing your questions, I know like when you're after doing 50 minus B questions, it's easy because you know it off by heart, but when you're under pressure in an exam, like that's when you make the mistakes. So don't be writing them out from your head. Look at the formula tables, like they're there to give you an advantage. Make sure you write it down properly, just to avoid making mistakes, okay? Another thing I have is just to make sure that you're using the SI units, so they're in your formula and tables as well. For when you answer a question, make sure your answer is in SI units. Now, a thing that has come up recently a lot, came up in 2018, so if you're doing your leaving cert in 2019, it's not likely to come up, but you never really know. Like I would never rely on predictions, so still make sure you're aware of it, just don't stress about it if you can't get it, is the hollow sphere. So what happens is you get told that a sphere has an inner radius, I'm going to call that R. A hollow sphere has the inner radius of R, and then our outer radius I'm going to call the big R. So we need to know is that when this sphere goes into water, the volume displaced, okay, volume displaced is going to be the volume of the outermost sphere, so that's the big R there. So when this goes into here, the volume, this is going to be the volume of water displaced here. is going to be the volume of the outermost sphere that like is completely submerged. But what we have is the actual volume of the object is the volume of the outer circle minus the volume, outer sphere minus the volume of the hollow sphere. So when we're dealing with upthrust, we use the outer volume only, okay? But when we're dealing with weight and like anything to do like actual weight of the object, we're using our actual volume of the object, which is the volume using this larger radius minus the volume we find using the thing. So, but like as I said earlier, you need to know your volumes of your shapes and stuff. So this is an example of where we'd be using the volume of the sphere formula. I think that's on page 10. Okay, so there it is. So what I did now is I made a list of all the formulae that have come up in the last few years. So like as you can see, we've got the floating upthrust formula comes up a lot. The upthrust, just like this is just to demonstrate to you like how important it is to know your formulas. So we've got the volume of a sphere here. It came up 3 times there. 2018 should be there as well. The hollow sphere like is how it comes up. So it's just important to know that you need to know where your formulas are and know the ones outside the tables. Okay. I wouldn't use this list before I've done the questions. Like it would kind of just to be referenced maybe after you've done a question to make sure you use the correct formulas. I'll put it up on my Instagram story at help I'm leaving cert, so you can check that out. Okay, so here is a list of questions I made that kind of have, sorry now the lights come back, tricks in them. So if you are doing your leaving cert in 2019, I'm sorry I won't have them all done before you go in, but if you're doing it in 2020 or onwards, I will have video tutorials for each of these up. I know it's a lot, like the applied maths paper, they love changing it up, like they love making it, they love throwing curveballs and like putting new things in, so that's why there's so many of them. But I'll do videos on them, and maybe the people in 2019, if you want to request a certain one, if you're having trouble with, you can give me a text on Instagram and I'll try and sort that out for you if I can. So that's it for today for hydrostatics. I'm trying to get an overview on pulleys done soon, so stay tuned for that. And if you want to get in contact with me, sorry, you can text me on Instagram at helpimaleavingcert, or email me at email@helpimaleavingcert, email@gmail.com, or you can just comment down below.